Hey guys, in this video I'm going to be going over the examples from the exponents part of the Precalc Advanced Summer Packet. So, example A, 4 times 2 to the 0 power minus 1. All right, you have to know order of operations here. So you might have heard a saying when you were little called, "Please excuse my dear Aunt Sally." All right, which means you should do what's in parentheses first, then exponents, then you should multiply, divide, followed by addition, and finally subtraction. So if we go in that order, we do have parentheses here. It's just a 2. There's really no math to do in the parentheses. So the next thing we should do is the exponent. What is 2 to the 0 power? Anything to the 0 power is always 1. So really that's 4 times 1 minus 1. 2 to the 0 just turned into a 1. All right, so we did our exponent. Next thing we should do is multiply. So we need to do 4 times 1, which is 4. Bring down that minus 1. And the last thing we should do, the only thing left, is subtract. 4 minus 1 is 3. All right, example B says simplify completely. All right, so again, if we do, please excuse my dear Aunt Sally, really no math to do in the parentheses. All right, you really can't do much. So now we should do the exponent. We have to square both the 3 and the x to the 4th. So think 3 squared, or 3 times 3, is 9. Then there's a rule. If you have an exponent raised to another exponent, you're allowed to multiply them together. So 4 times 2 is 8, so that's x to the 8th power. Example C. There's 2 ways to think about this, so I'm going to show you both. The first way is to think about when you have the same base, these are both x's, and you're dividing. There's a rule that you're allowed to subtract the exponents. So if you do that, 6 minus 9 is negative 3, so that would be x to the negative 3rd power. But then in math, you're really not supposed to leave negative exponents in your answer. So there's a rule that if it's a negative exponent, you're allowed to bring that term to the denominator, and its exponent just becomes positive. It was to the negative 3rd. Now since I moved it to the denominator, it becomes positive. That's one way to do it. Another method, let me write the original problem again, x to the 6th over x to the 9th. You can also think there's 6 x's on top, 9 on bottom. You could think about canceling what they have in common. So they both have 6 x's in common. We could cancel all 6 on top. If we cancel 6 on the bottom, we still have 3 left over. So we'd really be left with 1 over x to the 3rd. When there's nothing left in the numerator, you have to put a 1 in its spot. It's just kind of 2 ways to do the same thing. Example D says rewrite using only positive exponents. So again, that rule we talked about before, if you have a negative exponent, you're really allowed to move it. So this negative exponent is in the denominator. If you move this term to the numerator, it should become a positive exponent. So we'd be left with 5z to the 6th times z to the positive 4th. We just moved it, and the negative 4 became a positive 4. And then to simplify even further, if we have the same base, these are both z's, you're allowed to add your exponents. That's the rule. When you're multiplying 2 terms with the same base, you can add their exponents. 6 plus 4 is 10, so that would be 5z to the 10th power. All right. Next example, example E. It says simplify. It's that same rule we were just talking about. We're really multiplying these x's together. They have exponents on them. We're allowed to add the exponents together. 4 plus 3 is 7, so that's really 2x to the 7th power. Okay. That's all for exponents. Hope you guys found this video helpful.